In this video, we're going to derive the launch angle that yields the maximum range of a projectile that's launched along a flat ground. So we're going to say that a projectile starts at this position right here. And let's say that if we were to launch this projectile at a relatively low launch angle, right? Well, then the projectile isn't really going to travel that far of a distance, right? Likewise, if we were to launch this projectile at a really high angle, like if we were to throw a projectile at a really high angle, for instance like this, the projectile also isn't going to travel that far, right? But if we throw this projectile at a launch angle that's in between these two launch angles, for instance something like this, when the ball is going to travel even farther than these two launch angles. So then what launch angle will yield the maximum range of a projectile that's launched along this flat ground? Well, we know that the range of a projectile along a flat ground is just represented as this equation. R equals v0 squared sine of 2 theta all over g, where r is of course the range of the projectiles, the horizontal distance that the ball will travel. V0 is the initial velocity, theta is the launch angle, and g is the acceleration due to gravity. Now, we have to find the launch angle that yields the maximum range, right? So we need to find the launch angle that yields the maximum range. Now, we can think about this idea in a more basic sense. If this is pretty much the same thing as saying the x value that yields the maximum y value, right? That's basically what it is. And so let's just say we had a graph of x and y. In a really basic sense, if we had like a graph that looks something like this, well, we know that the maximum y value occurs at this point. So this would be the maximum y value. Well, the x value that yields this maximum y value is this one right here, right? And so this would be the x value that yields the maximum y value. Likewise, it works the same exact way for the launch angle that yields the maximum range, right? What we're going to do is we're just going to replace x with theta, right? So x gets replaced with theta, and y gets replaced with r, right? So really, this becomes the maximum range, right? So this is just the maximum r, and of course this is r. And so that's the whole idea of how this works. And so notice how the slope of the tangent line at the maximum range is equal to 0. So the derivative of r with respect to theta at this point right here, at the maximum range, is equal to 0. So the derivative of r with respect to theta is equal to 0. And so basically, what we have to do is we have to find theta. We have to find the launch angle when dr over d theta equals 0. And so this right here is the whole idea of what we're trying to do. And that's pretty much it. And so the way we can do that is we could take the derivative with respect to theta of both sides of this equation, right? So if we do that, right, take the derivative with respect to theta of both sides of this equation, right? This is pretty much what we're doing. And of course, on the left side of the equation, this is where we get dr over d theta, right? And on the right side of the equation, notice how we have these constants right here, right? v0 squared and g, these are just constants. And so we can pull them out of our derivative. And so really, we get v0 squared over g, and then we're multiplying by the derivative with respect to theta of the sine of 2 theta. So really, we're taking the derivative of the sine of 2 theta. Okay, now we know that we're setting dr over d theta equal to 0, right? So we get 0 equals v0 squared over g times the derivative. Okay, wait, we can find the derivative of this, right? Right, what is the derivative of the sine of 2 theta? Well, we know the derivative of sine is cosine. So we get cosine of 2 theta. And then remember, this right here is, we have to take the derivative of the inside part, which is 2 theta. We have to take the derivative of 2 theta, which is 2. And so this is just the idea of the chain rule, right? And also, remember, now we set dr over d theta equals 0. Now we gotta solve for theta, right? Because that would be the launch angle that we get. So since our equation is set equal to 0, that means we can pretty much eliminate our constants. Because we know if we were to divide our constants on both sides of the equation, well, this side of the equation remains 0, and our constants are pretty much eliminated, right? And so really what we get is 0 is equal to the cosine of 2 theta. And so this is really the equation that we're solving. And remember, when we're solving for the launch angle, this is a very important idea, right? When we're solving equations that are like this, we know that our launch angle ranges between 0 degrees and 90 degrees, right? We can either throw a ball close to 0 degree launch angle or close to a 90 degree launch angle. So really, theta has to range between 0 and 90 degrees. Right? It's a very important idea when solving this equation. Now, this is 2 theta, however, not theta. So really, if we wanted to know what 2 theta can range between, well, really, we just multiply 0 by 2 and multiply 90 by 2. So really, 2 theta can range between 0 degrees and 180 degrees. So we have to keep this in mind, really. All right, so we know pretty much when solving this equation, 2 theta equals, right? So 2 theta equals the cosine negative 1 of 0, right? That's really what it is, right? And we have to make sure that when we're evaluating this, that 2 theta is between 0 and 180 degrees. So we're thinking about cosine values that equal 0. Well, the cosine of 90 degrees equals 0, so the answer to this could be 90 degrees, right? Other angles that could yield that value include 270 degrees, negative 90 degrees, 450 degrees. But remember, these ones we don't care about. We care about the 90 degrees because 2 theta can only range between 0 and 180 degrees. So this right here is really what we get, all right? 2 theta equals 90 degrees. And then just solving for theta, we get that theta is equal to 45 degrees. And so this right here is the launch angle of the ball, pretty much the launch angle of our projectile that will yield the maximum range. And so yeah, this is where it comes from, right? The launch angle that yields the maximum range of a projectile launched along a flat ground, right? If we want the maximum horizontal distance traveled by a ball when we kick it off the ground, then that angle has to be 45 degrees from the ground. And that's pretty much it.